it's Miss Simpson here, and it's time for math today. We are still working on word problems. Shocker, we're going to be working on these for a while because they're some of the hardest things that we do in our whole lives when it comes to math. Because you can never figure out what in the world is the problem actually asking me to do. And that's why we do the UPS check strategy. Now, I've heard from several of you that you absolutely hate this strategy. While I do understand that it's a lot of work, I do want you to continue to do it. It is helpful. It helps you understand the problem, and I promise you it's going to benefit you when you get to your STAR test and all throughout your whole life. So today, we're actually going to be talking about a different kind of word problem. So we've done addition and subtraction. We've done one step. We've done two steps. We've done multiplication and division, one step, two steps. Today, we're going to talk about something that these sneaky people do to try and confuse your little brain. So before we do that, I'm just going to remind you about the UPS check strategy. The UPS check strategy is where we read the problem, we plan out, we solve it, and then we check it. Then what we do is we look at our keywords. Now, sometimes you're not going to be able to remember all of these. One for division that you really need to remember is the word each. That is one of the most common ones that I have seen on word problems this year. For addition, I always see all together. For subtraction, I see left over. I also see like maybe fewer, less than. But multiplication, sometimes I see each, and that's going to get you. But most of the time, I see each, and I see maybe in all. All right, so let's go ahead and we're going to try a few problems on our own, and then I'm going to let you do it by yourself. So here is a fast focus that we have been doing for the past little bit. They are going to try to confuse you. They're trying to confuse you. They're going to give you word problems like this one. They're going to give you word problems that give you units of measurement. Now, sometimes those units of measurement have nothing to do with your answer. It's literally just a label, as if saying crayons or something. So let's go ahead and do number 3. A red bucket holds 2.5 liters of water. A green bucket holds 0.5 more liters of water than the red bucket. A blue bucket holds as much water as the red and the green buckets combined. Which table shows this information? So, guess what? Liters. In this problem, liters is just a label. Don't let that confuse you. It's a label they're putting on these numbers, again, to try to confuse you. So let's go ahead and draw our UPS check box. So I want you to draw it and write UPS check. And then we are going to solve this problem. So let me find my pencils. So we need to first understand the problem. So we know the red bucket is the one who has 2.5 liters. Green says it's 0.5 more than red. Blue is saying that we have to do green plus red. It says red and green buckets combined. So that word combined means that it is adding. So let's underline what our question is. What table shows this information? So here's what I'm going to do. For my plan, I am going to go ahead and write out my equation. So in order to find the green bucket, if it's 0.5 more than red, I'm going to add the red plus the 0.5, and that will give me the green bucket. Then for the blue, I've kind of already done it. Blue, I'm going to add green bucket plus the red bucket, which is 2.5. Now let's go ahead and solve it. So the green bucket is going to be 2.5 plus 0.5. That would be 3. For the blue bucket, I'm going to have to line up my decimals. 3 plus 2.5, because this is the green bucket, this is the red bucket. So 0 plus 5 is 5. Add my decimal. 3 plus 2 is 5. So the blue bucket is 5.5. So we've got to find one that says red is 2.5. So all of them say red is 2.5. Then we have to find one that says green is 3. This one says green is 2. Won't work. Green is 3. Green is 3. Green is 3.5. That one won't work. Now 5.5 for blue. That one says 1.5, but that one says 5.5. So that's our answer. Now the leaders in this problem, they don't matter. They don't matter. Because the leaders are just a label, as if saying crayons or pencils or whatever. They don't matter. So in order to check this, I'm going to explain how it is reasonable. Because 3 plus 2 is 5. Because 3 plus 2 is about 5, so 5.5 makes sense. All right, so we are going to do the next one. Now for this, you might need your conversion chart. Sometimes they give you questions, like on the last one, where the measurement doesn't matter. It really doesn't matter. Sometimes they give you ones where you do need the conversion chart to figure it out. It kind of just depends. Sometimes you need it, sometimes you don't. So let's take a look at this one. The table below shows the number of ounces that are equivalent to different numbers of pounds. So guess what? This looks exactly like an input-output table to me, like we did with measurement. Input, output. So 2 times something was going to give you 32. 5 times that same number is going to give you 80. 6 times that same number is going to give you 96. So how many ounces are equivalent to 14 pounds? So again, pounds and ounces don't matter. This is an input-output table question. Pounds and ounces, again, don't matter. Your conversion chart doesn't matter. You just need to know your input and your output. You need to know the rule. So 2 times what is going to give you 32? So here's what I would do. I would take 2 and see how many times 2 can fit into 32. 2 can fit into 3 one time. 2 can fit into 12 6 times, and then 12 minus 12 is 0. So we know that I'm trying to figure out what we know here, that 2 times 16 equals 32. Does 5 times 16 equal 80? 6 times 5 is 30. 5 times 1 plus 3 is 80. So yes, we know that 5 times 16 equals 80. Do we know that 6 times 16, what's 6 times 16? 96. 6 times 16 equals 96. And that's going to go on and on and on and on and on. So my plan is to put 14 pounds, put a 14 over here, and carry out my rule. So my plan is to do 14 times 16 equals, and that will give me my answer. So right now I want you to pause the video and I want you to do 14 times 16, and then we will check your answer. Okay, so when I get 14 times 16, 6 times 4 is 24. 6 times 1 is 6, plus 2 is 8. Then I'm going to scratch, lay an egg. 4 times 1 is 4, and 1 times 1 is 1. Then you add them together. I got 224. So is that an answer choice here? Yes, it is J, 224. So in order to check this, we are going to explain why it is reasonable. So I know that these are pretty close. This one, if I round this one down, I get 10. And if I round this one, I get 20. So we can easily do 10 times 20, and 10 times 20 is 200. So if I'm going to estimate 10 times 20 is about 200, because if I round these, so 224 is reasonable. It makes sense. It's pretty close. All right. Let's take a look at this one, and then that will be the last one, and you will complete your assignment. Equivalent measures are shown in the table below. 3 meters is 300 centimeters. 5 is 500. 7 is 700. Based on the information in the table, how many centimeters are equivalent to 12 meters? So again, just like the one we just did, we have to write down what we know, and we don't really need our conversion chart on this one. We're not converting anything. Meters and centimeters doesn't matter. It's just an input-output table. So let's go ahead and find our rule. 3 times what equals 100? 300. 5 times what is 500? And 7 times what is 700? So you should know that you can use the rule 3 times blank equals 300. So 3 times 100. 5 times blank equals 500. So 5 times 100 equals 500. 7 times blank equals 700. Well, 7 times 100 equals 700. So they want us to know how many centimeters is equivalent to 12 meters. Well, I just got to continue the table, put 12 meters on that side. My plan is going to be to do 12 times 100. So right now I want you to solve that. I want you to do 12 times 100, and I want you to use the zeros trick. Use the zeros trick. All right, so to do the zeros trick, all you do is you first write down how many zeros you have in both the numbers, and then you cross them out, and then you'll do whatever's left. 12 times 1 is 12. So your answer is 1,200 centimeters. In order to check this, I am going to do it backwards. So I'm going to take 1,200, my answer, and I'm going to divide it by 100. Now, you guys don't know how to do this, but I'm going to give you a zeros trick. If you are multiplying, you add the zeros onto the end of the number. If you're dividing, you cross out. So there's a 0 on the left, and I can cross out a 0 on the right. 0 on the left, 0 on the right. So then you're just left with 12 divided by 1, and you should know that that is 12. So did I get my 12? Yes, I did. So is there an answer choice that is 1,200? There sure is. All right, so today for your assignment, you have word problems that are very similar. Don't let them trick you. You're not really going to need a conversion chart. You're only going to need to look at your paper and see if they're trying to trick you. Most of the time, meters, centimeters, liters, those don't matter. They only matter when you're doing your answer. That's it. They're just trying to trick you and thinking you're going to have to do conversions when you're really not. It's mainly just input-output tables and solving the word problem like normal. All right, so I'm going to post your assignment right down below. You guys have fun, and remember what we did in the video because it's very similar to what your assignment looks like.